We're going to go ahead and talk about our circles unit, very beginning. We're going to start off with vocabulary. Some of these words you already know. Some of them are going to be new and be very important that you guys remember what they are. The first one we're going to look at is circle. Do we really need to define circle? Do we need to talk about the definition here? Everybody knows it's that round thing, right? The center is pretty self-explanatory as well, right? It's going to be in the center of the circle. What else is happening with the center is it's going to be a point, and that's how we name the circle as well, okay? The next one's going to be your radius, which we should know. We've learned about radius years ago, right? So we're going to underline that with one of our colors, and then we're going to go trace it. Even though it's labeled, we want to make really pretty, nice, colorful notes, right? And all of our pictures are always in black and white. Your radius, as we know, is going to start at the center, and it's just going to go to some point on that circle, on the circle. Your diameter, we know, is going to go from one side of the circle through the center to the other side, and it also contains 2 radii. It's twice your radius. The circumference is just the length all the way around that circle line that you draw. How long is that? Okay. The next 4 are going to be our new ones. We're going to talk about arc. Your arc is going to be part of the length of this circle. Okay, so part of that circumference, part of that line that we draw that creates that circle. If we look over here, you can see the arc is labeled and it's kind of shaded, but it's just right there. It's just part. Just taking out a little piece of that circle. The next one's going to be a chord. With our highlighter, we want to highlight the word segment. We need to know, remember that a segment has a start and a stop. Okay? So this segment is going to start at some point on that circle. It's going to go through the circle, stay inside the circle, and it's going to end when it hits another part of the circle. So it's going to stay contained inside that circle. And if we look at where the chord is, we can see exactly what those words mean. Okay? It's going to stay within that circle. Does anybody notice another chord that's in there? What is it? No? Does anybody see another chord that starts on one side? What do you got? The diameter is also a chord. Get the door. We're going to talk about that one. We'll talk about that here in a minute. Exactly. Now with a chord, how we're going to remember that a chord is a segment is an extension chord. Doesn't an extension chord have a start and a stop? So it's like that. So our chord is going to be a segment, just like the radius and just like the diameter. Now we move on to the secant, okay? As we just heard, we were explaining, what ends up with a secant is it's going to be like the chord, except it's going to, whenever the 2 points that it hits on the circle, it's actually going to keep extending in both directions. So that's why we highlighted segment on chord, and we're going to highlight line on secant. Now what's happening is, we have this secant, it's going to enter into that circle at some point, it's going to go through, and it's going to exit somewhere else. So how we can remember the secant is right here when we see the secant going in, going through it, and exiting, it's slicing through that circle. So a secant slices. Or a secant slices. It's going to slice through that circle. The last one, the tangent. Oh, what I do want to say about that, about the secant, though, is that if you actually took off the arrows, you would have a chord, okay? But because we have those arrows, it's going in and then exiting out, we've got our secant. It's different. The last one, thank you, is going to be the tangent. Your tangent is also a line. So when we're mentioning tangent, we want to make sure that we're looking for a line. But the tangent is only going to touch that circle at one point. It's not going to go inside the circle. It's just going to brush up against it. So the tangent touches. The secant slices, the tangent touches. That's the difference between these two lines. So we'll put touches here. And we can outline or trace our tangent. So now we have beautiful colors on our notes. Right now, a tangent's going to have the arrows, because as we highlighted, a line. But very good question. We've got that line, so we have to have the arrows on both sides. That's going to be something else we'll talk about in a different set of notes. Yes, sir?
Not going to lie. Green is not a high tier color.
Well, it was a color I had to use. So let's take a look at our next part. We're going to use circle O below to name each of the follow I. I don't know what happened to NG. I guess NG just fell off somewhere. But we're going to go ahead and we're going to look through all of these, and we're going to say, okay, look at the picture and identify them. The first one we're going to do is we're going to identify the center. What's the center? O. Even if I didn't give you the picture and I told you circle O, you still know the center is O because that's how we name the circle. Number 2, we're going to name all the radii. Okay, radii is plural for radius. So, what's a radius we got here? That's a point. No, it's an angle. That's not even an angle. We are looking at segments, so we need the start and the stop. Okay, good. Segment OQ. Write them small because there are 3 of them. So we have segment OQ. Good. Now we look at ON. It's part of the diameter, which gave you away, number 3. But remember, your diameter is compiled of 2 radii. So we have ON. Good. And segment OL. Remember, we have to have these segment bars above to let us know that these are segments, because these symbols change based on what we're talking about. And your diameter would be? So you going to be the only one to give me answers?
Yes.
I'm going to make you give all the answers now. Okay, very good question, because we need to remember about naming segments and lines. We're using 2 points, but the one thing, the freedom you have, is what order they go in. Yeah, you can name it segment LN, or you can just name it segment NL, whichever one you would like to. Thank you for asking, so we could get a reminder there. Our secant is going to slice. Good. We have line MN. So this is why we need those symbols above it, because we're talking about a line now, so exactly what a line looks like with those arrowheads, that needs to be the symbol that goes above it. Your tangent's just going to touch it and leave. Good. Line NP. And our last one, our chord. Good. Segment ML. And more specifically, our chord not including the diameter. All right, so little turtle is telling us move on. You guys can tell what the theme is of this unit. Yes, very close. Let's go ahead and get a little more detailed with the arcs. We got a vocabulary out of the way. Let's get into arcs. As is said on the front page, your arc is defined as part of the length of around a circle. So here we'll fill in part of the length around a circle. And obviously I'll give you time to write that out. So it's part of the length around a circle. So you guys finish that. I'm going to continue talking. There are 2 main arcs that we talk about here. You're going to have minor arcs, and you're going to have major arcs. So these are 2 arcs that we're going to talk about. We are going to define each one, And then we're going to use a diagram, and it says 1. We're going to find a couple of them, because I'm going to find one, and you guys are going to find one for me. Okay? Your minor arc is going to be an arc less than 180 degrees. So we got an arc that is less than 180 degrees. When we name this arc, like with a segment with a line, we're going to have 2 letters, and it's going to be where, like a segment, it's going to be where it starts and where it stops. Okay? So we find 2 points that connect on the arc, that make an arc that's less than 180 degrees, and we're going to name it with the 2 letters. So here we'll write in named with 2 letters. Sorry for the sloppy handwriting. Named with 2 letters. So an example could be arc FG. Does everybody agree that's less than 180 degrees? Yeah. So from F to G, we'll write in FG, and just like the line in the segment, we need a symbol, and the symbol is exactly what it is. It's going to be an arc. So we put an arc over it. Who has another arc for me? Okay, so I'm hearing JH. Good. What was another one? Okay, yep, we got GH. We can also take a look at GJ. It's combining 2 arcs together, but it's still a complete arc that's less than 180 degrees. Sometimes it might be an arc that's going to include more than 1 arc. When we get to our major arc, take a wild guess what this definition is. Yep, it's going to be more than that 180 degrees. So an arc more than 180 degrees. Now we have to change how we name it, because if we just name it with 2 letters, and I tell you, let's go back to FG. Well, starting at F, I don't know whether I'm supposed to go clockwise or counterclockwise. Am I getting the minor arc or am I getting the major arc? So in order to actually name a major arc so that the person reading and you're telling you, whatever, you need to include, so that way they know whether you're talking about major or minor. What were you going to say? We got to pick up another letter on the way. Okay? So we're going to name this with 3 letters. Very good. Oops. Named. We're going to name it with 3 letters. What is it? You say L? L's in the middle. L's the angle. I'm going to go ahead and give you the first one. The reason why is because I want you guys to see what happens if between the starting and the ending, if there are more than 1 letter. What letter do you choose? So if I want to stick with F and G as the starting and stopping, whenever I'm going around getting to G, I've got to pick up a letter on my way. You do not name it F, J, H, G. 3 letters, not 4. So which letter do you pick up? Either one. Doesn't matter. Doesn't matter which one. So we can name this FJG or FHG, whichever one you want. I'm going to call it FJG because that's the first one I said. FJ. Good. What could another major arc be? Okay, we got it. We have 3 letters. So we go from J to F to G. That looks like it's over 180 degrees to me. Bless you. So J, F, G. Good. Very good question. How do you know? We're going to get into this a little bit later, but if you have a diameter, you'll be able to tell a lot easier. Right now, it's going to be a basis of they're either going to give you a measurement or, as much as I always say don't assume, just by looking at the picture, we're just going to kind of have to assume. And I don't see any diameters to really help us out with that, so we just kind of have to look at and assume on this one. So, now that we know about major and minor arcs, we know what an arc is, let's talk about an arc measure. We're going to be talking about two different things, arc measure and arc length. They are different. Okay? Arc measure, if you see measure, arc measure, or the measure of arc whatever, in your problem, this is what you need to follow. Your arc measure is always going to be measured in degrees. And in my opinion, this is one of the easiest parts of this whole unit with all of our finding arcs and lengths and stuff. Your arc is going to be defined by the central angle. And the central angle is exactly what it sounds like. It's the angle in the center. It's created by radii from that center point. The two sides are going to, the two radii are going to go out, and they're going to create an arc. Okay, so you have this angle here, central angle, and it creates that arc. And it's going to be, what ends up having, the reason it says defined by your central angle is because that central angle and its arc are the exact same measurement. Exact same. No formula needed. So here, if I'm looking for arc GH, what's that measurement? What's the measure? If that arc is the same as the central angle that creates it, what's that arc measurement? It's going to be 130 degrees. Now, we're talking about angles in a circle. We can more look at the arcs. If I have several arcs, like these pictures show, if I take all of those arcs and I add them all together, how many degrees should I get? Good, 360 degrees. So all of the angles, as well as all of the central angles right here, are going to add to 360 degrees. So we have this magic number of 360 degrees. So we're going to use this diagram, and we're going to go ahead and solve for x, which is going to be this central angle right here, GFJ. So using that information we just talked about, we're going to go ahead and add that x plus the 130 plus the other angle that we have, which is how much? Good. And they're going to all add together to equal 360. And I do understand that some of you are like, well, why can't I just add the 2 and subtract from 360? You can, and that's what we're going to do. I'm showing it algebraically, solving for x, because if you ever get a problem where, let's say x had a coefficient, or let's say that it said 2x plus 8, another one was 3x minus 6, and then you had a 4x plus 19. You're going to have to solve it like this, adding all of them together and equaling it to 360. So real quick, we'll go through this. We have our 130 and our 90 that are like terms. We're going to go ahead and, like I said, you're just going to be adding them and subtracting for 360, right? We add them together. We're going to get x plus 220 equals 360.
Wow.
Then, not divide. You got to subtract that 220 for both sides. What is x going to equal?
140.
Good. So a lot of you guys calculating that on your head. So that 360 is going to be important. So the last problem here on arc measure, we're going to take a look at the measurement of angle PCM. So we go from P to C to M. What's that measurement? Yeah, I know you guys are kind of like, what? It's written right there for you, 117 degrees. Just making sure that you can read this labeled right. Now we want the measurement of arc PM. So we're looking at a minor, I just gave you the answer to D, but I know you guys would know it anyway. We're looking for arc PM. So what would that measurement be? Remember that your measurement of arc PM, the measurement of the arc, is equal to the measurement of that central angle, in this case, angle PCM. So whatever that central angle's measurement is, when it opens up to create that arc is the exact same measurement. So again, what's the measurement of this arc? Good. The last one here now wants the measurement of arc PNM. Exactly. All we're going to do is, those are the only two arcs, we're just going to subtract the 117 from that 360 all the way around. So 316, sorry, 6D, minus that 117. What is it? Good. We got some fast typers. You can also check, looking at the number of letters that are there, whether it's major or minor, and check out the number, the actual measurement, and make sure that if it's a minor arc, if it's only got 2 letters, it better not be above 180. If it has 3 letters, it better not be below 180. So the last question, whenever I was putting our little turtles in here, little cute guy here, I guess I didn't realize that was a question, and I guess the answer to this question is the turtle. So we're just right off to the side. We got room over here. We're going to talk about what kind of arc PM is, and how do we know. So what kind of arc is arc PM? And I kind of slipped on that one earlier. So we got a minor arc. Good. How do I know? There we go. I was waiting for the other one too, because there are actually 2 ways. So good on the less than 180 degrees. And we'll put only 2 letters. Did you have a question?
So the blue, the one that you highlighted blue, that's the major arc?
Absolutely, yes. The one I have in blue here, PNM, is a major arc. 1, because it's over 180. 2, because it was named with 3 letters. Very good. So arc measure, degrees, this 360, focusing on those central angles. Okay, or I might give you the arc and I want the central angle. Still the same exact thing. So let's talk about arc length now. Your arc length is going to be measured in inches, centimeters, things like that, okay? So things are going to change, like I said. Now, if you're looking at assignment or you're looking at, doing your quiz or something, and you see length, you want to make sure that you come to this section here, okay? You want to look at that measure or length. Which one do they want? The length of your arc is not only determined by the central angle, but also the radius. So now they have to give us a measurement of that radius. It's also going to become from part of a fraction of your total circumference. The reason I'm telling you that is because when we get the formula, you're going to see the symbol pi. All right? So the original formula is a proportion setup, where you'd end up having to cross-multiply things, and this and that, and yada yada. And then Miss Escamilla came up to me and was like, why? Just go ahead and cross-multiply. Just give them this more simple formula. So that's why my anchor chart isn't up for this, because I had the more difficult formula. I was like, you know what? You're right. The state does not say I have to teach it that way. Okay? You just need to be able to find the arc length. So a much more simplistic way of writing this formula, it's going to be a fraction formula. So our calculators, we're going to want to do the control divide, that fraction function. We're going to have that pi that I told you about, the apple pie. Did I forget to mention we're having pi today? And then we're going to have our radius. Took a while. I hear the chuckles now. And then we're going to have theta. Okay, that little theta. Now Susan looks like, what? We'll finish this out and then we'll explain everything. Underneath, we're going to have 180. You will always be given the formula. In fact, the quiz that has arc length on it has the formula written right next to each problem that has arc length. So that's going to help you between measure and arc length as well. We're going to note here, we know that R is going to stand for radius. I'm pretty good at that. That theta symbol, which we saw in trigonometry, means an angle measurement. This is going to be the central angle. Yes, sir. So let's go ahead, and one other thing that I want to note before we move on to the first problem is in geometry. Do not ever, ever, ever use 3.14 for pi. Unless it specifically says, and in this unit everything has been created and I haven't seen it anywhere. Okay? You're going to use the pi symbol in whatever calculator you're using. Okay? So let's go ahead and note here, do not use 3.14. We're going to use the pi symbol. The reason why is 3.14 is rounded. And I have actually had students go and do the same problem, once using 3.14, once using pi, and it's a surprise how different the answers come out to be. So let's take a look at this first example here. I'm going to go ahead and rewrite my formula so I have it right here in front of me. And we're going to find the radius, and we're going to find the central angle, and we're going to substitute them in. So we take a look at the circle over here. What is that 10 centimeters labeling?
The diameter?
This is going to be your diameter. Is that what we need? No. What do we want?
Radius?
I feel like we're doing like a little cheer. And we all know how to find that radius. What's that radius? Yeah, we're going to divide by 2, 5. So we don't need the diameter, we need R, radius. We are looking for arc ZY. So find arc ZY so that we can find its central angle. Then its central angle right there in the center that creates this arc is going to be 130 degrees. So now we have the two numbers we need to put into that calculator. Okay? So we're going to take this, bring down pi, plug in for our radius, plug in for theta, our central angle. Do not forget to put it over 180 though. Like I said, on the calculator, I'm going to suggest that you use the fraction function, because I don't want you to do all the multiplication in the numerator and then round that and divide, because you still could end up a tenth or 2 or 3 off. Okay? So when we go to our calculator, if I can clear mine so you don't see answers to the assignment, the control divide gives us that fraction function we've talked about before. Your pi button. Does anybody see pi? The very, very bottom, all the way on the left, the second to last, or second from the bottom. Now, when you push this, you're going to see a bunch of symbols come up. You will never use any of those other symbols. The reason I'm saying that is because you see the theta symbol, you see a degree symbol. You're never plugging that into the calculator. The only thing that you're going to use on this is that pi symbol. So all you have to do is press pi button and then press enter. And then we want to plug in the rest. You can do parentheses or just put times 5 times the 130. We're going to scroll down to the denominator and get that 180 down there. And we will round to the nearest tenth. And when we press enter, we get approximately. And thank you for those of you who are plugging in the calculator, because you need to be using that pi symbol. Quiz, test. How do you do pi? I'm not telling you. Okay? The last one, go ahead and try this on your own. right? Try it on your own. Give some time. Work it out. Write the formula down. I mean, I'll even get the formula there for you. Your pi times radius times your central angle. Locate what you need. Plug it in. Put it into your calculator. So our radius, already given to us. Remember, your radius is halfway across the circle, diameter is all the way. So this will be 4. Your theta, or your central angle, 75. So substituting in, we've got pi times 4 times that 75. And we should have plugged that into our calculator. And what is the length?
5.2.
Good, 5.2. And now we have this really, really happy turtle letting us know, yay, we're done with the notes. Now we can do our assignment, right?